Welcome to our mathematics class. Today, we will get to know an equation that is related to the following pictures. To check your readiness on this topic, try to answer a pre-test. Read each question carefully and choose a letter that corresponds to the correct answer. I want you to look at the following pictures and tell me what is common to all of them. Very good. Each picture shows curves. These curves are called parabolic curves. Do you know that this spectacular shape contributed to the beauty of math? It is because parabolic curve and structures are all defined by a quadratic equation. Will you give more examples of objects with parabolic curves? A smiley also shows a parabolic curve. So a reminder to everyone to always start your day with a smile because life is too short to be sad. In your previous years, you encountered a polynomial like 2x squared plus 7x plus 3. What do you remember about a polynomial like this? We know it very well that a polynomial with 3 terms is called a trinomial. As you can see, our polynomial is raised to the second power. We therefore say that the degree of the polynomial is 2. Let's equate our polynomial to 0. Since an equal sign is already present, we now call this a polynomial equation. In mathematics, an equation in second degree is called a quadratic equation. It is written in the form ax squared plus bx plus c equals 0. Ax squared is the quadratic term, bx is the linear term, while c is called a free term or a constant term. Ax squared plus bx plus c equals 0 is the standard form of a quadratic equation, where a, b, and c are real numbers or known numbers, while x is an unknown variable. In the equation, a is the coefficient of x squared, which may be positive or negative, but not equal to 0. Why do you think a is not possible to be 0? Once a is equal to 0 and substitute it to the equation, what will happen to the quadratic equation? Correct. It will eliminate the quadratic term, or our quadratic term will turn out to be 0, and the resulting equation will be a linear equation. An equation whose unknown is raised to 1 or a first degree equation. Aside from the given example, let me show you more examples of a quadratic equation. Again, what made these equations quadratic? Great, because they are all raised to the second power. Let's check if you are now able to identify a quadratic equation. Just say yes if the equation that I am going to show you is a quadratic, no if it is not. 25 minus p squared equals 4p. Is it a quadratic equation? Yes, it's a quadratic equation. How about 2n cubed minus n squared equals 10? No, it's not. Let's go to 3v plus 8 equals 5. It's not a quadratic equation. 6 minus 2t plus 3t squared equals 0. Yes, it's a quadratic equation. How about 4m minus 2m squared equals negative 2m squared plus 1? Is it a quadratic equation? No, it's not. Why? because once we combine negative 2m squared and negative 2m squared by APE, it will eliminate our quadratic term. N squared equals 0. Do you think it's a quadratic equation? Yes, it's a quadratic equation. You all did great. So this time, let's go back to our list of examples. Are all equations written in standard form? No, as in the case of 3x squared equals 9 and 2x squared minus 3 equals 6x. A quadratic equation can be arranged to standard form if ax squared plus bx plus c is equated to 0. From our example, 3x squared equals 9, we need to make the right side equal to 0. So in order to do that, we need to add negative 9 on both sides of the equation, applying addition property of equality. And this will give us 3x squared minus 9 equals 0. Observe that the equation consists only of two terms. What term is missing in our quadratic equation? Yes, it's the linear term. Therefore, 3x squared minus 9 equals 0 is now the standard form of our quadratic equation, wherein a is 3, b is 0, and c is negative 9. Let's go to our second example. In here, we need to make the right side of the equation equal to 0. Again, by addition property of equality, we add negative 6x on both sides of the equation, giving us 2x squared minus 3 minus 6x equals 0, which we still need to arrange into quadratic term, linear term, and constant term. So we have 2x squared minus 6x minus 3 equals 0 as the standard form of our quadratic equation. So in here, the numerical value of a is 2, b is negative 6, and c is negative 3. What about the following equations? Are these equations quadratic? Maybe some of you would say yes, while others will disagree. These equations are quadratic. They are referred to as hidden quadratic equation. They can be expanded using distributive property or Polynomial method. Let's expand 3x times the quantity of x minus 2 by distributive property. Multiplying 3x times x and 3x times negative 2 will give us 3x squared minus 6x. And that will be equal to 10. Applying APE, since we need to make the right side 0, we add negative 10 on both sides, giving us 3x squared minus 6x minus 10 equals 0. Again, this is now the standard form of our quadratic equation, wherein the numerical value of a is 3, b is negative 6, and c is negative 10. Next, in our second equation, let's find the product of the left side using Polynomial method. Multiplying 2x times x will give us 2x squared. Multiplying the outer terms, 2x times negative 1 is negative 2x. 5 times x is 5x. And multiplying the last terms, 5 and negative 1 is negative 5. Next is we combine like terms. Negative 2x plus 5x is 3x, making our equation 2x squared plus 3x minus 5 equals negative 6. Since we need to make this side equal to 0, by applying APE, we add 6 on both sides, giving us 2x squared plus 3x plus 1 equals 0. which is already the standard form of our quadratic equation, where the value of A is 2, B is 3, and C is 1. Let us have a practice on writing equation in standard form. As I flash the equation, you tell me its standard form. Will you transform the equation x minus 5 times the quantity of x plus 5 equal to 0 in standard form? Great! X squared minus 25 equals 0 is correct. How about x times the quantity of 2x minus 3 equals 0? What is its standard form? Good job! Transform x minus 7 times the quantity of x plus 7 equals 2x into its standard form. Bravo! X squared minus 2x minus 49 is equal to 0. Very good. Next, will you transform the equation x plus 6 times the quantity of x plus 6 equals 0? X squared plus 12x plus 36 is equal to 0 is correct. Excellent! How about x minus 1 times the quantity of 2x plus 3 equals 10? Fantastic! X squared plus x minus 13 equals 0 is correct. Shania and Afia got the following values of A, B, and C when they express negative 8x plus 7 equals 3x squared into its standard form. Who do you think got the correct answer? Explain and justify your answer.